Okay, guys, I'm going to do 3 examples, and there's going to be a lot of algebra review involved in this. So this is B-7. We're going to evaluate the limits. So here we're going to see what happens when you can't direct substitute, what another option is. So here's example 1. You always try to direct substitute first. And to test whether you even can or not, look at the denominator and see if you direct substituted into the denominator, would you end up with 0? Because if the denominator is 0, then that's undefined, so it doesn't work. So if you plug -4 in here, you'd get -4 plus 4, so the denominator would be 0. So we can't direct substitute. So when you cannot direct substitute, you do the following. You go equals limit, and then you just leave a blank like that. Okay, that's the first thing that you do. The reason I say to do this first is because the biggest mistake that I see students make, one of the biggest mistakes, is that they forget to have this limit here. All right, so after you do that, you take the input of this limit and you bring it off to the side. Okay, so we're going to do an aside. So this is x squared plus 3x minus 4, x plus 4. And you try to factor it or you try to do things to it so that you're going to get the denominator to cancel, because it's the denominator that's creating a problem for us here. All right, so this is a quadratic. So you could think of two numbers that multiply to make -4 and add to make +3. So x squared, wait a minute, they multiply to make -4. Oh yeah, okay, so plus 4x minus 1x minus 4. All right, and then this is, all right, so I'll just say like this is the top. And then I can take out an x, take out a -1. All right, so this actually is x minus 1, x plus 4 over x plus 4, and the denominator did cancel, and that's what we wanted to happen. So after you've gone off to the side and you try to get the denominator to cancel, or you try to get whatever factor was causing the problem, so whatever factor was making the denominator 0, if you can get that to cancel, afterwards you go back up into the limit. So this is actually x minus 1. Right, so that's actually x minus 1. Okay, and then you try to direct substitute again. So now can we direct substitute? Yes. So this is -4 minus 1. That's -5. All right. The biggest thing that's going to cause people problems, I think, is being rusty on algebra. So you just need a lot of practice. So in the practice, I'm just going to give you tons and tons of examples, and then you just keep practicing until you feel comfortable. And you don't have to do it all in one sitting, but keep coming back to it. You want these to be fast. You don't want to get tripped up on the algebra. And if you find the algebra is tripping you up, that just means you need more practice. Okay, so this one, we're evaluating this limit. You try to direct substitute. I'm going to focus on the denominator and see if it becomes 0 if I do. Plug in 0, yes. 2 times 0 is 0. So I can't direct substitute right now. So I'm going to go like this, and then I'm going to do another aside. All right, so I'm going to take I'm going to take the input on the limit. It's 2x. All right, and what's giving me the problem here is the x. All right, so if I could get this x to cancel, then I will be able to direct substitute. All right, so what could we do here? There's a couple things. You could, if you see a difference of 2 squares, which I do, you could factor the top using that. Or you can like expand this. So let me take the top. um, 5 plus x, 5 plus x minus 25. All right. My new camera is coming in, guys. I hate the quality of this. I strongly dislike the quality of this camera. All right, so this is going to be 25 plus 5x plus 5x plus x squared minus 25. Oh, so look at that. Those 25s cancel. So this is 10x plus x squared. All right, now let me put the top back up here. Over 2x. All right. So what can I do? Oh, I could take an x out. 10 plus x over 2x. And then it works. Those x's cancel. And once I got them to cancel, because remember it was that x that was making the denominator 0. It was that x that was preventing me from being able to direct substitute. So now that it canceled, I'll go back up here. Whoops, I just hit the camera. And then you try to direct substitute again. And this time it's going to work. So when I direct substitute, I get 10 plus 0 over 2. That's 10 over 2. And that is 5. Okay, let me do one more because, I want you to see a few algebra things to jog your memory. All right, we did a lot of these. We worked with a lot of expressions like this last year. Okay, I made a point to give you guys a lot of these last year. Actually, I should get the stuff we did last year and just post it in our document in case you want to just practice simplifying expressions like these without the limit. Okay, and the reason I gave you a lot of these last year is because I knew we'd have to do this. So, all right, I tried to do direct substitution. So 5. I'm going to focus on the denominator. 2 times 5 minus 10, that's 10 minus 10, that's 0. It's not going to work. So I go equals the limit as x approaches 5, and then leave a blank. And then I'm going to take this over here. Did I write aside last time? Yeah, I did. So here's an aside. 3 over x minus 3 over 5 over 2x minus 10. All right, so what we would do last year is this. We would want to get, if we had a single fraction over a single fraction, then we could do keep, change, flip. So that's what we want to do. So up here, guys, what is the common denominator? I'll go like this, yeah. All right, so I want a single fraction over a single fraction. So I put the 2x minus 10 over 1. We want the 2x minus 10 to cancel. And when you do keep, change, flip, yeah, I think it's gonna. All right, now, okay, so here I have a denominator of x and a denominator of 5. All right, so my common denominator needs to include a factor of x and a factor of 5. So that would be 5x. All right. Now, what do I have to multiply? What factor am I missing for this denominator to be 5x? I'm missing an x. What factor am I missing for this denominator to be 5x? I'm missing a factor of 5. All right, now so now both of my denominators are going to be 5x. So I already brought that down. And then this minus sign, I'll just bring down here. 5 times 3 is 15. All right, now we can do keep, change, flip. Keep, change, flip. All right, and if you're rusty, guys, just practice, practice, practice. I'll put up a ton of practice. Because like I said, this needs to be fast. All right, now we multiply straight across. All right, so this 2x minus 10, it still didn't cancel. All right, so you should ask yourself, can you factor anything here? Don't distribute the 5x. Okay, that's going to be counterproductive. Because then you definitely won't be able to see as clearly what cancels. Well, let's try to take out some greatest common factors. Can I take a GCF out of here? Yes, I could take a 3 out. 5 minus x. So I've still got that 5x times. What can I take out of here? I can take a 2 out. Guys, we practiced a lot of this last year also. This 5 minus x and this x minus 5, they don't cancel to make a 1 over 1, but they do cancel to make a negative 1 over 1. And now I said earlier, guys, I said it was the 2x minus 10 that we wanted to cancel, but it was actually inside of this. If you factored out the 2 initially, you would have seen this x minus 5. So it's actually this x minus 5 factor that's the problem. Because if you plug the 5 in to the x minus 5, you'd get a factor of 0 in the denominator, which would make the whole denominator 0. All right, so what is this? This is negative 3 over 10x. And now this goes back up here. Negative 3 over 10x. And now you can direct substitute. So this is negative 3 over 10 times 5. That's negative 3 over 50. All right, guys, so I wanted to do all those examples just so you could see some algebra review. So all of this aside stuff, we did a lot of last year, okay? And you were very good at it. So it just might take some practice to get it back. Okay, I will talk to you later.